I'm Jessica, and this is a sneak peek into my PhD. Along with my supervisors, there are many helping hands that made this project possible, all of them acknowledged here. Together we studied the freshwater production from clay formations in foothill zones. But our study was purely experimental. Our aim was to experimentally simulate the diagenetic processes of fluid and heat flow and mechanical compaction. Our objective was to use general water chemistry and specifically chlorine and bromine isotopic tracers to track the evolution of freshwater production with time. A specifically designed large odometric type cell was connected to an oil pressure generator for inducing vertical axial stress and to a set of pressure pumps for generating pore fluid pressure at both sample sites. It could also be reversed to allow us to continuously collect water expelled from the clay as it was compacted. The system was also equipped with a thermal heating regulation and, of course, a data acquisition system. We did 3 compaction experiments, which lasted up to around 200 days each. First, we saturated the clay in the cell, slowly, and then compacted it in several steps of increasing vertical stress and temperature, up to 150 megapascal and 150 degrees Celsius, while maintaining the pore pressure fluid as close as possible to 45 megapascal, and continuously monitoring the axial deformation, as well as the volume and composition of water expelled with each consecutive compaction step. Through a water and chemical mass balance of the system, we could therefore calculate what would be the remaining pore water composition after each step. And state-of-the-art modeling software developed by the BRGM helped us to understand what proportion of that water was the result of clay mineral dehydration. We found that the chemistry and isotope behavior is considerably different between swelling clay and non-swelling clay. In our study, we saw a general decrease of cation and anion concentrations in the expelled water for swelling clay, while its concentration in the remaining pore water slightly increases. This was not the case for non-swelling clay. Water expelled during the compaction experiment at higher temperatures also reached a lower salinity. We also observed that as bromine is much more effectively filtered by geological clay membranes than chlorine, due to its much lower natural abundance, this translates into a larger range of isotopic fractionation for bromine, up to 1.5 per mol, than for chlorine, down to 0.5 per mol, in all 3 of our compaction experiments. And with that, I thank you for your attention and your interest.